Welcome to Preferred Utilities Technical Seminar on Carbon Reduction Strategies for the Boiler Room. Carbon emission reduction is a high priority for a lot of universities and municipalities that operate central steam and hot water plants. Preferred converted the heating boilers in our factory to renewable fuel in June of 2018. When we studied our fuel bill and our electricity bills and applied some conversions from the EPA website, we found that before we switched to renewable fuel, approximately half of our carbon emissions came from our boilers. The other half was from our electricity consumption. Today, we're going to talk about renewable fuels and how you can greatly reduce the carbon emissions from your heating boilers. In our previous Renewable Fuels webinar, we went into more depth into the regulatory environment behind the push for carbon reduction. We're not going to repeat this topic, but the previous webinar is on YouTube. Also in the last webinar, we talked about carbon reduction through efficiency improvements, adding variable speed drives to your larger motors, and switching from coal or oil to natural gas. In this webinar, we're going to focus on fuel switching from fossil fuels to renewable fuels. We're not going to discuss landfill gas, digester gas, or solid biomass. Landfill gas and digester gas are great sources of renewable, clean-burning biofuel, but they require a lot of resources and real estate most central plants don't have access to. I love this photograph because it shows some sort of farming operation, a biogas lagoon, and 3 digesters under construction. This gives you an idea of the real estate required for landfill gas or digester gas, which just isn't an option for most central heating plant facilities. We're also not going to talk about solid fuel biomass, and for the same reason. It requires a lot of real estate. Solid fuel biomass requires a large pile of biomass to be stored on site. You will also need a boiler capable of burning solid fuels, typically a spreader stoker-fired boiler like the one shown in this picture. Detroit Stoker and several other companies can set you up with one of these boilers to suit your needs. The technology is well established, but it has a really big footprint. And for the sake of discussion in this webinar, we're going to assume most of the facility operators and engineers on this webinar just don't have that kind of real estate to put in a large solid fuel biomass plant at their campus. So, Preferred Utilities works with 2 suppliers of liquid renewable fuels. The advantages of liquid renewable fuels include they can be burned in any fire tube or water tube boiler. They can be burned in your existing boilers. New burners or controls may or may not be required depending on what you have existing. Liquid biofuels can be transported by rail car or truck, and you can likely buy them through your existing fuel supplier. Liquid biofuels have NOx, SOx, and CO emissions similar to number 2 oil, but 80 to 95% less carbon emissions, so air permitting should be an easy process. Preferred Utilities works with 2 suppliers of liquid renewable fuels. Ensyn manufactures what's called Renewable Fuel Oil. We also work with REG that manufactures Biodiesel Residual Oil. Both of these fuels can be transported by rail or car or by truck to your facility, and this unphotoshopped photo is proof. This internet meme illustrates one of the misconceptions around biomass. So one of the nicknames for renewable fuel oil is liquid trees. And it's not quite accurate. It's more like liquid tree trimmings. And I'll explain. The feedstock for renewable fuel oil comes from either harvest residues or commercial thinnings from a sustainably managed forest. Harvest residues would most likely either be left in the forest to decompose or burned if not used for RFO. The forester that works with Ensyn is required to provide an affidavit that feedstock has met the above criteria and that the feedstock did not originate from environmentally sensitive land or government-owned land. And each batch of fuel has a certificate that follows it which details where the feedstock originated. Ensyn's feedstock suppliers are generally larger logging operations because they have the ability to provide the necessary certification for the RFS2 program. So this is a more accurate picture of where the feedstock comes from for Ensyn's RFO. You see a densely packed forest on the left and a thinned out forest on the right. Forest managers will tell you the forest on the right will support a greater diversity of wildlife and is less susceptible to a devastating forest fire. The end products of Ensyn's biomass process are liquid smoke that's used as an additive in food products, renewable feedstock sold to petroleum refineries, and RFO for steam and hot water plants. By the way, when you burn RFO in your boiler, it does produce a very nice wood smoke aroma that smells a lot like liquid smoke. Because RFO is biogenic, greenhouse gas emissions from RFO are about 88% lower than number 2 oil and 82% lower than natural gas. It's not 100% carbon reduction because it takes some fossil fuel to make the renewable fuel oil and to transport it to the facility. Preferred utilities can convert virtually any fire tube or water tube boiler to fire RFO. However, RFO is acidic, so everything in contact with it must be made of stainless steel prior to combustion. Once we burn the RFO, it's not acidic anymore, so the carbon steel in your boiler tubes and your economizer and your stack are going to be fine as long as we take our normal precautions to make sure that we don't condense anywhere in the flue. Preferred Utilities has converted fossil fuel-fired boilers to RFO firing at Bates College, where we did 2 of their boilers, at Youngstown Thermal, and for the CNRC in Ontario, Canada. Ensyn typically amortizes the cost of the fuel conversion in a 5-year fuel contract. Even with the fuel switching costs, the price of RFO is close to the price of natural gas on a BTU basis. Preferred has converted 2 boilers at Bates College for renewable fuel oil. In the second boiler retrofit, we switched out just the internals of their Cleaver-Brooks boiler to burn RFO. The green parts in the above picture on the right is the new preferred burner insert. That's the only thing we really changed on the boiler. That boiler had already been upgraded to preferred controls a few years ago. As soon as our technicians finish tuning up the new burners, Bates issues a press release touting their success, reducing greenhouse gas emissions at their campus. In fact, after Preferred converted the second boiler at Bates, the university declared their campus to be carbon neutral, which generated a lot of publicity. If you Google Bates College carbon reduction, like I did, you're going to find a bunch of stories from a bunch of different news outlets talking about how this college was able to achieve carbon neutrality. Because RFO is acidic, the oil storage tank, the pumps, the piping, and the burner need to be made from stainless steel. The price of RFO is about the same or lower than natural gas. The ideal RFO candidate is a facility that is budgeted for new tanks, pumps, and burners and will burn enough RFO for a quick payback. Switching gears to REG and bioresidual oil, bioresidual oil is made by a company called Renewable Energy Group. They are the largest producer of biodiesel in the United States. Biodiesel residual oil is a waste product of biodiesel production, ethanol production, and recycled cooking oil. Think of biodiesel residual oil as the number 6 oil of biodiesel. It has the appearance of dirty French fry oil, but it has actually undergone extensive cleaning to remove impurities such as ash, heavy metals, and water. Preferred Utilities started burning bioresidual oil in our 2 shop boilers in June of 2018. The burner on the left is a 1950s vintage Preferred rotary cup burner designed to fire number 6 oil. The burner on the right is our state-of-the-art low-emissions Ranger burner. They are both burning bioresidual oil now. This is the startup data from one of the 2 boilers. Important things to note include bioresidual oil needs to be heated to 160 to 165 degrees F. If existing burners are using number 6 or number 4 oil, they will have a pump and heater set that could be reused. Combustion efficiency is similar to that of number 2 oil. Excess air ran 15 to 20% throughout the firing rate, which is considered good for a liquid fuel. Stack CO, carbon monoxide, is less than 10 parts per million. This is considered clean combustion for any fuel. And finally, opacity was 0 throughout the boiler load. In fact, these burners were firing number 6 oil before we changed them out to bioresidual oil. It took no new equipment to set them up to burn bioresidual oil. It only required a retune. So the key results of the bioresidual oil firing in our factory was that the oil needed to be heated to about 162 degrees. We keep it warm to about 100 degrees in our tank to keep it pumpable. And then we use an electric trim heater to bring it up to 162 degrees before it's burned. CO emissions and opacity indicated clean combustion. Excess air levels are comparable to number 2 oil, and the boiler efficiency was the same as number 2 oil. Preferred's 2 boilers have been firing bioresidual oil since June 2018 with no unplanned downtime. We actually took both boilers down over the summer and did a thorough internal inspection and found that there was no unusual accumulation of ash or anything else in the furnace or on the tubes. So bioresidual oil can be fired in most existing boilers and burners. It needs to be heated, and it's more expensive than natural gas, but it's less expensive than number 2 oil. So the ideal candidate for burning bioresidual oil is a facility that already has a pump and heater set. They can reduce their greenhouse gas emissions by up to 80% and spend less for fuel than number 2 oil. There are a lot of facilities in the Northeast that are still burning number 6 oil and are planning to switch to number 2 oil in the near future. These plants can switch to RFO or bioresidual oil and exceed all existing and proposed carbon emission reduction goals. So how do you switch to renewable fuel? First, you call Preferred, and Preferred will send combustion engineers out to evaluate your existing burners and boilers. We're going to see whether the plan is to burn RFO or bioresidual oil, whether you're going to need new burners, new pumps, pump and heater set. We'll estimate the capital cost of any changes to existing equipment. You, the facility, will enter a contract directly with the fuel supplier. And once fuel has been delivered on site, Preferred technicians or an authorized contractor will modify the burners and controls as needed. And after your first fuel delivery, a Preferred technician will retune your burners on the renewable fuel of your choice. Preferred's technicians will train your operators to burn the new fuel. This includes operation of any new equipment. They'll train your operators to identify what a normal flame appearance looks like and what the flame appearance might change to if a situation required a technician to come out again. We will talk to your operators about what to expect in the strainer baskets, and we'll teach them how to maintain the fuel in the main storage tanks. It's important for bioresidual oil that the oil in the tank be kept at least about 100 degrees. That way it doesn't form a substance that looks a lot like butter in the tank. So we had a little bit of this occur in our main storage tank. We talked to the people at REG, And they said to just recirculate a little bit of hot fuel back to the tanks occasionally, and that keeps the oil warm enough to be pumpable all the time. Preferred can set up secure remote monitoring of your boilers. With the Preferred cloud server, facility people or Preferred technicians can monitor the status of existing boilers. If a boiler goes down or has an alarm, a notification can be sent by email or text. Onboard diagnostics can help us troubleshoot a problem remotely to get the boiler up and running as quickly as possible. Preferred's cloud server operates on a secure Verizon cellular VPN network. Your data does not flow through your facility's IT network, and it never hits the public internet. So stay tuned to David Bond's LinkedIn page for more information on our next webinar. In our next webinar, we'll present the results of several new biofuel projects that are in the works now, and we'll provide an update on the changing regulatory environment for renewable fuels. So that's it for today. I thank you very much for attending this webinar today. We're going to go live now with Greg Gosselin with Ensyn and answer all the questions that have come in during this presentation. Thank you. Okay, this is David with Preferred.
Hi, it's Greg with Ensyn.
All right, it looks like the technology is working. This is David Ofoh with Preferred Utilities. First of all, I want to thank Greg Gosselin for being on. Greg Gosselin is from Ensyn, and they are the manufacturer of RFO that I talked about earlier. RFO, sometimes referred to as liquid trees, or more accurately, it should be liquid tree trimmings. I want to start off with, I spent a couple of slides sort of bashing solid fuel biomass, not because it isn't a perfectly good technology, it's an established technology, it will reduce carbon emissions as well, but most of the campuses and most of the prospects I see for renewable fuels just don't have that kind of real estate. And in fact, I visited a campus a few years ago. This is a school known for their basketball program, but I'm sure you can go there and get a degree in anything. And they had several coal-fired boilers, and they were considering converting those coal-fired boilers to natural gas. And their number one motivation was they wanted to recover the real estate that was underneath their gigantic coal pile and put a building up. So even campuses that do have the real estate have better uses for the real estate than a gigantic solid biofuels plant. And the genius really of Ensyn and RFO is that they take all that biomass processing and move it off-site from the university or the central plant, because they take the biomass, the solid biomass, and turn it into a liquid fuel and then deliver the liquid fuel to the campus. And the campuses are already set up to burn liquid fuels. You know, virtually every campus I visit still has number 2 oil as a backup fuel. So really, it's a way of moving all that real estate intensive fuel processing off-site in a way. Is that a correct characterization, Greg?
Yeah, that's correct. So we take all of the wood handling equipment that you would need on the front end of a biomass plant, and we take that headache and deliver a BTU-rich fuel to the school, so that you don't have to have all that biomass handling equipment.
And your facilities are acres and acres and acres. We're not talking about small plants here, right?
Yeah, a typical 20 million gallon per year RFO manufacturing plant will use 400 bone dry tons of biomass per day.
Okay. When I was in college getting my bachelor's degree, I worked for the campus newspaper because it was a good paying job, and we printed 5 newspapers a week. Now that campus newspaper hasn't actually printed a paper in 15 years. And nobody buys a newspaper anymore. Everybody just reads it online. So as the demand for pulp and paper products has gone down, are there more commercial forestry operations with older trees? So, and what I'm getting at, is there a bigger supply of biomass now because of decreased demand for newspapers and magazines?
In most areas, the annual growth of the forest exceeds the annual harvest. So there's an excess supply of biomass in nearly all areas of the country. And what you see in states like Maine and Minnesota, there's been a tremendous reduction in paper mills and biomass electricity plants. So the commercial loggers do not have an outlet for their low-grade material, which would be the branches, the tops, the butts of the trees that we use to make RFO. So an RFO manufacturing facility can fill that void that the loggers are seeing now.
Wow, so you're making use of a product really that would be going to waste if you weren't turning it into liquid fuel.
That's correct, and we're also making the logging operators more sustainable, because being able to sell the low-grade material gives them added revenue and makes their logging operation more profitable.
Wow, that's amazing. So what would you say is the limiting factor then to RFO production? Is it the number and the capacity of your plants right now? So the limiting factor is not timber. You've got plenty of feedstock.
Yeah, feedstock supply is plentiful. So really what we're trying to do currently is develop a critical mass of customers in geographic regions in order to build plants local to our customers. The idea is not to truck or use rail to transport RFO for hundreds and hundreds of miles. We would much rather build plants in closer proximity to our customers, so that both the feedstock is trucked a short distance as well as the finished product to the customers trucked a short distance.
So it's a little bit of a chicken and egg phenomenon. Ensyn and Preferred need to convert more boilers over to RFO, and as that demand increases, your production will keep up.
That's absolutely correct. I am of the belief that if we build it, the customers will come. However, those who invest money in big projects would prefer to see the contracts first.
I gotcha. Okay. Let's go to the email and start taking questions from the field. Okay, so first, Greg, how do you quantify the carbon emissions reduction of RFO versus natural gas or number 2 oil?
So we've conducted a life cycle analysis we had a third-party engineering firm do this for RFO, natural gas, and number 2 oil. So the cradle to grave basically is what we're doing. So the emissions that you'll see in the reduction from natural gas or number 2 oil includes the cost for harvesting our feedstock, the cost for making our fuel, and the cost for delivering our fuel. So that's in the life cycle analysis. And also for number 2 oil and natural gas, we're also attributing cradle to grave emissions for them as well.
Okay. Does RFO require any state or local approvals to be used as a boiler fuel?
Yeah, it's going to vary by state. However, in all of our installations so far, the existing emissions permits have been, they've had RFO added administratively. There's been no re-permitting required. And that goes for a customer in New Hampshire that only burns 300,000 gallons a year to a customer in Ohio that's a Title V customer. So all of the permits have been able to be altered administratively without a whole lot of additional engineering and permitting work.
Okay, so amending an existing air permit is much easier than applying for a brand new air permit, I take it.
That's correct.
Okay, and like I mentioned in the presentation earlier, traditional emissions, what old people like I am think of emissions are NOx, CO, and SOx. Those are comparable to number 2 oil. So the difference really is carbon, and the carbon reduction is on average 82% versus natural gas and 88% versus number two oil. So they see it as a huge emissions reduction. So is the amendment to the air permit a rubber stamp? Is it just procedural?
There's two ways to look at emissions. There's life cycle emissions, which is where the 82 and 88% reductions come into play. And then there's the emissions that go up the stack. That does not take into account the renewable nature of the fuel. So the emissions up the stack, that's what the state regulatory agency is going to be concerned with, not necessarily with the life cycle emissions. So that's where you're going to see comparisons on SOx, NOx, CO, particulate. The two areas where you'll see we're a little bit higher in NOx and a little bit higher in particulate than your typical natural gas and number two oil.
Okay, I gotcha. How long have boilers been firing RFO? And have those boilers been inspected for unusual corrosion or ash buildup? Greg, I remember you guys firing RFO on our boilers. Gosh, that must have been 6 or 7 years ago. When was the first time we did this on someone else's boiler?
We're in our 6th winter at Memorial Hospital. So that boiler started in July of 2014. And what we see typically from an ash buildup is that if you were cleaning your boiler one time per year with gas or oil, if you're burning RFO, you're probably going to increase that cleaning to 2 times per year. And primarily that's because our product is actually a wood product, and wood has ash in it. So we're developing a little ash in that boiler that would require that additional cleaning. From a corrosion standpoint, the boiler inspector for Memorial Hospital, and primarily they're concerned with the water side of the boiler. However, last summer, the inspector, knowing that they had been burning RFO for a number of years now, looked at the fire side of the boiler to see if there was any increased corrosion, and he gave it a clean bill of health and saw no corrosion to the fire side of the boiler after 5 years of burning RFO. So that we've had great results with that.
Okay, that's fantastic. And that's an important concern because both fire tube and water tube boilers, water tubes especially, last a very long time. I visited a site just last week that had boilers from 1957 and we're still firing them. And the company that made that boiler had been out of business for 20 years.
I believe the boiler at Youngstown Thermal is in 1941.
Wow. Yeah, it's amazing how long they last when they're well taken care of. So it's good that the boiler got the extra inspection. And by the way, I just want to point out that water tube boiler and fire tube boiler designs are very, very old. They really haven't changed a ton in the last 100 years. So your basic Scotch Marine boiler or your Liberty Marine type water tube boiler, they were originally designed to burn number 6 or number 4 fuel oil, because that's what people burned back when these water tube and fire tube designs first originated. So they really were designed to burn liquid fuel, heavy liquid fuel. So let's see, we covered that one already. How much fuel does my plant need to burn to be a good candidate for RFO firing? There's got to be a lower limit where it just isn't economical, right?
Yeah, typically the lower limit would be 500,000 gallons of oil or 70,000 decatherms of gas. That doesn't mean that a smaller plant could not convert. However, the economics are more challenging the less fuel you burn. The conversion cost is very similar whether you burn 300,000 gallons or you burn 2 million gallons. So obviously, the more fuel you burn, the better the economics are for the conversion.
All right. I'm going to take your number and do a little bit of math here as we go. So 500,000 gallons per year. And we'll multiply that by about 142,000 BTUs per gallon. And then we'll divide that by, what is it, 8760 hours in a year? 8760 divide. So we're talking about 8 million BTUs per hour if it ran 100%. So if we had a 50% capacity factor, we're looking at about 16 million BTUs per hour. So maybe that's about a 400 or 500 horsepower boiler.
Yeah, so a 200 horsepower boiler is approximately 8.5 MMBTUs per hour. So we've done our smallest boiler that we converted is 150 horsepower. That's a little on the small side, but yeah, we can 200 horsepower and above can certainly be converted with no problem.
Yeah, and that 200 horsepower boiler is a very small boiler for a central steam plant. I think the two little boilers in our shop are both 150s, and all they do is heat a small manufacturing plant. It's not really a central steam plant at all. So let me check my email, make sure we don't have any other questions that came in while we were talking. Nope, that's it. Greg, did you have anything you wanted to add before we signed off?
No, just I would like to thank everyone for attending.
Okay, so this webinar, including the questions and answers, will get uploaded onto YouTube. You can go to the preferred utilities page on YouTube where you'll be able to find it. If you have any questions about burning renewable fuel at your site, my email address is up on the webinar. You can email me. If you have a question that relates more to Ensyn, I'll forward that on to Greg, and one of us will get back to you. And we have experienced engineers who can come to your site and evaluate your existing boiler equipment and what needs to be done to switch you over to a renewable fuel. And you can reap the benefit of that 80+% carbon reduction, and maybe get to where Bates College is now, where their campus is completely carbon neutral. So once again, Greg, thank you for doing this. I think this went off well, and I look forward to seeing you next time.
Oh, thank you.